seen earlier. Okay, so basically the fundamental part. Okay, so the fundamental part is basically you are dealing with motor assembly. Okay, and hence you are rotating the disc. Okay, then your optical assembly, right? Okay, through which you are reading and writing the data. Am I right? Okay, so in this you are having the laser, the mirror, and the lenses. Okay, and for rotation of these two means to rotate the disk as well as the adjustment of mirror, lenses, and so on. Okay, so here you are having the servo system, because if you try to concentrate, okay, there is not only a single motor to rotate the disk, but also you have to open and eject the tray. Okay, then the second one is to adjust the lens, because the data is written spirally on the disk. Am I right? Okay, so as to read each and every track, the lens should be moved forward and backward to read all the tracks. Okay, so how many basically motors you require? The first is to rotate the disk. Okay, then for the tray, am I right? And third for the lens or laser. Okay, so these three motors are required. Okay, so that basically uh, done with the help of servo system and sync mechanism, because sync is very very important. Okay, only rotation of the disk is not the main purpose, because see, I'll uh, demonstrate you. This is a compact disk. Okay, so you are writing the data right from the center to the edges. Okay, and what we have seen is in compact disks, uh, the rpm, okay, the speed of rotation is varied from 200 to 500 rpm. Okay, why this variation is existing, that is the question. Okay, so this variation is existing because when you are reading, when you are reading the data at the center location. Okay, let us consider in this region. Okay, so in this region you are having very what we can say small radius as compared to the center. Okay, the radius is very small within this region tracks. Okay, but when you go in the middle part, okay, so the radii are quite larger than that. And finally, when you are moving out to the circumference, am I right? So the at the circumference the radii would be larger enough. Okay, so as to read the data, okay, the disk has to be, the rotation of the disk has to be varied. Okay, because these are closely the radii are small, then moderate, and then larger. Okay, that is why this variation in the speed is there. Okay, understood why there is a differentiation between, or why there is a what we can say lower extremity and upper extremities for the rotation of the disk. Okay, so for that purpose we need this motor to be varied based upon the position of the laser at which track the laser has been pointed. With reference to that, the disk has been rotated with that particular rotational speed. Okay, and finally, when you want to insert or take back your disk, the tray has to be opened. For that also we require one motor, right? Okay, so coming to next, this is optical assembly. The data is read with the help of what? Photo diode. Okay, this photodiode is important. And for the control and synchronization, we are having control and sync mechanism, okay, over here. And all this, we are working with the digital data, so we require here crystal oscillator, right? So here you can read or write the data onto the disk. So this is the basic assembly which is considered when you are writing the data. The two parts are very important. Okay, so what are those two parts? The optical assembly and the servo assembly. In servo we want three motors, right? So for the rotation of the disk, okay, for ejecting the tray, and for the laser, right? Now coming back to our lecture, okay, so here this is the simple block diagram of the CD audio playback. Okay, so what you can find over here is the signal is sorry, okay, the signal is coming from the detector, right? Then the signal is decoded, then error detection circuitry is there, okay, then upsampler whenever there is a loss in the data, then we are having the digital low pass filter, okay, then delta sigma modulator, and the signal is passed through analog low pass filter, okay, and then to the sound, because what we have seen is we are having analog, okay, as far as audio signals are concerned, analog audio, then there is a box and output is again analog, okay. So what inside is, here you are dealing with some part ADC, okay, sorry, ADC, then some operation, and again DAC, digital to analog converter. So this is the whole idea, okay. So we are concentrating one by one on this one, okay. So this is what is basically this readout is concerned, okay. So the CD technology is better as far as error control job is concerned, that we have seen earlier, okay. So there are two types of errors present in the CD, namely random error caused by air bubbles or pits inaccuracies, because what happens whenever you are writing the data, there might be some minute artifacts while writing the data on the disk, okay. So that could be the possible cause of the error, okay. And the burst error caused by scratches and fingerprints, because we basically don't know if someone doesn't know the idea to handle the disk, okay. So it can also cause this error, okay. So basically you can note down the errors, okay, are of two types as far as compact discs are concerned, okay. First one is random and another one is burst, okay. So how this random error, what are the sources of random error, okay. So basically it is caused while writing the data, am I right? While writing the data, or the pit inaccuracies, if the pit is not properly placed on the track with the correct dimensions of its deepness inside, the width and the length, okay, so that cause an error. And second one is the burst, that is caused by scratches and fingerprints, okay, agreed, okay. So these error appears in the form of click sound at the time of playback. Here if the data is not that much clear at that time, we get a click sound, okay, because that doesn't carry any kind of information, and here we are talking about the audio signals, am I right? So that can cause the error. The error control is exercised in the following way. First of all, a digit is employed to correct that error occurred. Okay, if a certain bit is incorrect, then it is simply inverted to carry out the correction. Okay, so here we are employing the digit. Otherwise, if there is a sufficient redundancy in the code, then we can use this redundancy to determine the correct data value. If you are having the redundancy, then you can overcome. Okay, so basically the burst. Okay, burst error. Though the data is properly written on the disk, but due to lack of handling the disk, that data can't be retrieved. Okay, so due to redundancy, you can also retrieve that one. Otherwise, incorrect value can be corrected by interpolling between the neighboring sample, as we have seen, or many of you are familiar with the image processing or signal processing techniques, where we can determine the what we can say, the middle value by means of its neighbor. Okay, so there are various techniques of interpolation. Okay, so rigorously we are using those techniques to predict that missing data as far as signals and images are concerned, right? And the last option is to mute the unreliable data value, because that is producing some different sound, clicking sound, or some undesirable sound. So we can mute that one. This is possible because unless the muting exceed a few millisecond, it is not noticed by the listener. Okay, if it is that much important. Okay, so the data from the error detector is then sampled by increasing n minus 1. Okay, increasing all 0 words between PCM samples. Okay, this increases the effective sampling rate. Okay, so sorry the new sampling rate is this one. Okay, and this is upsampling. Okay, so basically you are using n as 256, so the sample rate could be increased from 44.1 kilohertz to up to 11.3 megahertz. Okay, so this is the updated sampling rate. This increases in sampling rate brings the adjacent sample very close to each other. Means, why we are doing this? Because we are going to increase the number of elements for that particular thing. Let me illustrate this one. For example, if we are having a line, okay, if we are having a line, so as to describe this line, I can draw this point, this point, this point, this point, and this point. Okay, so all points are collinear. Okay, so if you zoom out, it appears to be a line. But still, if I increase the sampling, okay, so I can insert few more points in this one. Okay, so now the number of sample points for this one, okay, for this line has been increased. Again, you can increase these sample points. Okay, now what is the purpose of this one? The purpose behind this one is you are adding much more details to describe this one, because why we are digitizing the perfect reconstruction of the data. Okay, or the what we can say, the correct resemblance of that particular thing in digital. Okay, analog thing in digital. Okay, can be better employed when you are increasing the sample, because that incorporates more details. Am I right? So this is very important. Okay, so this is very basic analogy where you can judge why and more number of samples are needed. Okay, right. Okay, so this increases the sample rate, brings the adjacent sample to be very close to each other, and the amplitude difference between adjacent sample will be very very small. Okay, now this allows us to use the delta sigma modulator as a 1 bit DAC. Again, we are converting all the digital data, because what the upsampling and all those things we can do as far as we are having the digital data. Okay, but at the last we have to listen the sound which is analog, then we need to convert that particular thing into analog domain. So for that purpose we are employing here the delta sigma modulator. Okay, and the last block in this one is the analog low pass filter. Okay, this one, analog low pass filter, that is a simple Butterworth low pass filter having the bandwidth of 20 kilohertz. Okay, so why? Because is the audio range is within 20 hertz to 20 kilohertz. Am I right? So this is how this works. Okay, understood. So basically what we have seen is the signal is coming from the detector, then it is decoded. There there might be some errors. Okay, so as to overcome the error, we are predicting uh, the loss of data with reference to, so by incorporating some samples by means of upsampler, then filtering it, then again converting that digital data into analog, then again applying the low pass filter which is within the range of audio signals, and then we could be able to listen the sound. Okay, so this is how happens with the video data also. Okay, if provided, if your television is analog, so as to visualize the on analog video data. Am I right? So all of you need to follow the same funda, because nothing is varied. Okay, all the CDs, DVDs, HD DVDs, and Blu-ray DVDs, the fundamental is same. Only some techniques are newer, and for those techniques you have to concentrate. Okay, what extra other thing has been employed? Okay, as far as the variations in the discs are concerned. Am I right? Okay, so the ITU standard. Okay, for voice encoding has been mentioned over here. Okay, so if it is asked in the examination, you must know few more points for this thing. Okay, so G.177, that covers unsam sorry, that covers uncompressed audio encoding at the rate of 64 kbps. I'm sorry, 64 kbps. Then another standard, G.722, this is used for hi-fi high fidelity voice. Okay, and that covers the audio codec at the same rate, that is 64 kbps. Next one is G.723, that is the dual rate audio codec, G.728. Okay, that covers audio codec at 16 kbps, 16. And the last one is G.729, that this covers the audio codec at the rate of 8 kbps. Okay, so you can find the various ITU standards for the voice encoding techniques at various data rates. Okay, so you just remember these figures, at which data rate which technique is used, because this standard is globally accepted, right? So in the last lecture, okay, so let us go with the last lecture. What we have seen is, okay, this one. Okay, so this diagram we have seen that the differentiation between the compact disc, okay, digital video or versatile disc, high definition DVD, and Blu-ray DVD. Okay, so basic differentiation is what kind of optical source that we are using to read and write the data on the disk. Okay, so here we are having a infrared, red laser, and for these two we are using blue laser. Am I right? Okay, so this is the basic and fundamental differentiation. Again, coming to the second fundamental differentiation is the physical parameters which are present, okay, on the disk in the form of data. Okay, so basically we are dealing with the track length, track width, track depth, and inter track differences. Are you getting? So all these parameters are there. Then again, coming to the much more details about the wavelength of infrared, red laser and blue laser that has been used in this one. Okay, so coming back to our lecture. So the discs are classified in CD, DVD, DVD, HD, DVD, Blu-ray, DVD. Okay, as far as capacities are concerned, it is of 700 MBs. Then coming to the DVD. Okay, so in DVD you can find there are certain variation or various type of discs which are present over here. Okay, so DVD audio, DVD video, DVD read only memory, DVD recording, DVD read write. Okay, in this also you can get the simple audio CD, video CD. Okay, the recording CD and RWCD. Okay, and CD also. But here you find the fixed storage capacity of the disk, that is 700. But here there are certain variations which are present as far as DVDs are concerned. Okay, so this SSSL, that is single side single layer. Let me write it down. Single side single layer. Okay, so single side single layer DVD 4.7 GB. Okay, then single side double layer. In the same side, if you are having double layers, then it is 8.5 GB. Then double side single layer. Okay, that is 9.4 GB, and double side double layer, that is 17.1 GB. Okay, so this is what is the variation which is present as far as DVDs are concerned. Okay, now coming to the HD DVD. Okay, so in HD DVD, only what is the basic differentiation between this DVD and HD DVD? The format or video codec that we are using, that is the first difference. The second difference is its storage capacity, right? So here we can go up to how much? 7.1 GB. But as far as HD DVDs are concerned, either for single side 15 GB and double side 30 GB. And the most important fact is that the video codec that has been used as far as HD DVDs are concerned, that is H.264 or MPEG 4. Okay, so this H.263 and H.264 we have seen at the time of second unit. Am I right? The basic video compression techniques involving it is basically based on the same platform in which we are compressing the images by means of JPG. First of all, let us take the image, divide that image into 8 by 8 blocks. Then with reference to quantization table, okay, we are performing the discrete cosine transformation. Okay, then again after transformation we are having the what we can say quantization, and finally encoding. Basically we are using Huffman encoding for that, and finally we are compressing the data. But as far as videos are concerned, okay, so last time we have seen there are various frames. Okay, uh, what in this operation, I guess I, B and P frame that we have seen in that one. Okay, so I frame, B frame and P frame. Okay, so what is the what we can say what is the full form of this I, B and P frame? Do you know? Because first of all, this we are having the sorry, this we are having the reference frame, the first frame. Okay, so that is intra coded Okay, frame, intra coded, all of you know, I guess. Intra intra coded frame. Okay, so that is the first frame, because so as to compress the second and third and fourth and subsequent frames, we need some basic reference. For example, in object detection, in what trajectory the object is moving, for that purpose we must know the initial position of the object. Okay, and how do we know the initial position of the object? By referring the very first frame. Okay, and that frame is called as intracoded frame. Okay, then B is the bidirectional frame. Sorry, bidirectional frame. And P is what? Predicted frame. Predicted frame. Now how that sequence would be? First of all, iframe. Okay, so that is the your basic frame comes into picture. Okay, then the second one is your bidirectional. Means bidirectional, what is the meaning of bidirectional? Because we are taking the reference from the intermediate frame, and we are predict sorry intra-coded frame, and we are predicting what could be the next frame. Okay, so it is the condition where we are observing both in the past, and by means of the past data we are predicting the future data, right? So again, this bidirectional, again this bidirectional, and this predicted. Okay, so this is happening because what happens, if a certain image, sorry, if a certain video is having for example duration of 1 minute, okay, that is 60 seconds. Okay, and what is our what we can say sampling rate, or the video rate? It is 25 fps, 25 frames per second. So in 60 seconds, how many frames are there? 60 multiplied by 25, so 150, these many images. And if you apply the compression, basically, though it is a video, but still we are applying the basic part is of image compression, because video is nothing but the sequence of the images, am I right? So if you apply jpg on each and every image, it will increases the computational complexity. It will also takes the time to compress each and every image present over there. Okay, so it is time consuming, as well as the uh, hardware resources which are required for that operation would be larger enough, and you could get the result. Okay, the result production time would be very very large. That is why we are not at all doing that, but instead of that we are using the first frame, and we are subsequently going for the bidirectional, and then to the predicted frame. Okay, so the sequence would be I B P and so on. So it basically depends on you how many B frames has to be incorporated. Okay, so based upon that the compression quality depends. Okay, so what we are talking about is the differentiation between the DVD and HD DVD is the size and the technique used for video compression. Okay, great. Now coming to the Blu-ray DVDs. Okay, so basically again these are differed only with respect to what? The size. The single layer is 25 GB and double sided is 50 GB. Okay, understood? This part is very very clear, right? So there is no that much difficulty for the understanding of these things, I guess, right? So in examination they can ask you the basic difference, to write the basic differentiation between these four parameters, sorry, these four things. Okay, So you must know the parameters. What could be the parameters? The first parameter is what? Made of. Okay, so everything is made up of plastic, right? The second one is immunity to dust and scratches. Okay, because it totally depends upon the protection layer that has been applied on the disk. So basically only CD is not having that one, but the upper versions like DVD, HD DVD and Blu-ray DVD are having this protection layer for that. Okay, then the third one is the diameter. For already we have discussed the diameter for every disk is same, that is 12 centimeters. Coming to the next parameter, thickness. Okay, so thickness is also same. So can you tell me what is the thickness? The thickness is 1.2 millimeter. The distance between adjacent track. Okay, so this is important. What we have seen in CDs, basically CDs and VCDs. Okay, both are same. Okay, so inter-track distance between CDs and VCDs is 1.6 micrometer, whereas in DVD and HD DVD and Blu-ray DVD it is different. We have seen yesterday. Okay, so this could be the fifth parameter of differentiation. Coming to the next, what is the minimum pit length? This is also important. Okay, then what kind of laser you have used? Okay, so in series we are having infrared. Okay, then in DVD we are having what? It is the visible red laser, and in HD DVD and Blu-ray DVD we are having visible blue laser. Okay, right? So next differentiation parameter would be the technology. Okay, so what kind of technology is used? Okay, to store the data. Okay, then ninth difference would be the storage. Okay, so what is the storage capacity of each and every disk? Okay, then the next parameter is what kind of video compression technique is used, right? So you must know what kind of video compression technique is used. So in audio CDs it is MP3, for video CDs it is MPG-1, in DVD it is MPG-2. Okay, and in HD DVD and Blu-ray DVD it is MPG-2 and 4, right? Then coming to the next differentiation parameter, that is bit rate. Okay, so what is the bit rate for the data? Okay, so that you must know, right? And the last parameter would be video recording duration. Okay, basically that is the playback time. Okay, so based upon that, up to how much time you can play the data, or if it is a video, then how by how much time you can get the data, right? So basically 80 minutes approximately can be dedicated for the CDs and VCDs. Okay, audio CDs and VCDs. And based upon, if as far as DVDs are concerned, at that moment it varies with respect to these parameters, whether it is a single side single layer, single side double layer, double side single layer, or double side double layer. Okay, so the playback time that you must know. So basically the question can be asked for 5 to 6 marks. So the differentiation parameters would be must be more than double. Okay, so each parameter is evaluated for half marks. Okay, so you must know all the differentiation. Okay, now coming to the next one is the audio data compression technique. Okay, so audio data compression technique, we are using the first one is, sorry, MP3. Okay, so MP3 is used, then advanced audio coding technique can be used, and this is second one. The third one is FLAC. the FLAC technique is used, that is free lossless audio codec. Okay, so these three techniques, which are those? MP3, advanced audio coding, and free lossless audio coding or codec, FLAC. Okay, so these three techniques can be used for the audio data compression. Okay, now coming to the next topic, and that is the block diagram of audio CD player. Okay, so this can be asked in the examination either for CD or DVD. Okay, so in this we are having this box is the optical assembly. Okay, where you can read or write the data, okay, from the disk. Basically, here are the power supply, the front panel display, system control, and laser power control are connected to the optical assembly over here, in which we are having the laser diode and photodiode. Laser diode is used as an optical source, and photodiode is used as a sensor to read the data coming out of disk. Okay, so basically, whatever may be the data which is coming out of photodiode assembly is given to the RF amplifier. Okay, then the decoder, then the digital filter. Okay, then DAC, digital to analog converter, and then analog preamplifier, and we are having the stereo sounds over here, the left channel sound and right channel sound. Okay, so here only we are focusing on audio CD player, that is why there is no concern of video. Are you getting what I'm saying? If there is a concern of video, then again we need to put some other block which could be able to retrieve the video information from that particular disk. Okay, so basically the digital signal is coming from this one, is amplified, then decoded, then filtered, then converted into analog, and then again through amplifier given to the stereo channel speaker. Okay, so for this purpose here you can see the motors or the rotating assembly, that is focus servo. This focus servo motor is used for the laser, because as you see this block is connected to this one. So this laser focus means, I mean to say, on which track you need to focus, from which track you need to retrieve the data. Okay, so basically if you consider this CD, okay, so suppose these are the tracks. Okay, and if I want to focus at this point and this point, okay, and this point, so my laser detector should move. Okay, so if it is a laser detector, okay, in this direction, either upside or downside. Okay, so as to read the track, so as to move that, we are having the tracking servo, right? The focusing servo is to focus on the track. Okay, and related assembly is associated with that one, and then carriage servo, so as to open and close the drive for the CD. Okay, so this is very basic simple diagram in which you have to narrate the optical assembly, okay, then front panel assembly, then how you are converting your digital audio data into analog audio data, and what are the various servos are associated with that one, that you have to focus in this diagram. Okay, understood? This diagram is very simple. Then coming to the next one is the DVD. Okay, so this is the block diagram of DVD recording system. I'm sorry, DVD recording system. Okay, so in this what we are doing is we are recording the sound as well as the video. Okay, So from video camera, what you are getting, the three channels of the video, as we have seen in the very first unit, Y, U and V. Okay, so what do you mean by Y, U and V? This is the luminance and these two are the chrominance signal, color difference signals basically. As we know that which signal can't be transmitted, which signal can't be transmitted, because Y is the combination of RG, sorry, Y is the combination of RG and B. Okay, so which signals, which signal can't be transmitted? Can you just chat me in the chat window whether it is R minus Y, whether it is G minus Y, whether it is B minus Y. Yes, can you recall that equation? What is the what we can say, the multiplier thing for RGB as far as Y is concerned? Y equals to something into R plus something into G plus something into B. 0.3 R, 0.59 G and 0.11 B. So G minus Y is not transmitted, hence we are having R minus Y and B minus Y as a color difference signals. Okay, so don't forget this one, because everywhere we need this particular information. Okay, now coming to this one, from video camera we are having luminance and color difference signals YUV. Okay, and these are digitally uncompressed video. Okay, then here for the compression of video we are using what, MPEG2 compression. Now just recall, just now we have discussed the differentiation between the CD DVD, HD DVD and Blu-ray DVD. In that we have also mentioned what kind of compression technique we have used. Okay, so here for digital data, MPEG2 compression is used to compress the video information as far as DVDs are concerned. Understood? Okay. And the next part is the, from microphone we are compressing this one with some audio compression technique. The video compressed data, audio compressed data are mixed together by employing the multiplexer. Okay, and the combined data of audio and video with synchronization is given to the recording system, which writes the synchronized information of the video and audio onto the DVD. Am I right? Okay, so this is very simple. Now coming to this one, if you try to recall the second unit, okay, in which we were dealing with the digital television, at that time we have seen, okay, these parameters, okay, for luminance signals and color signals, because on DVD we are writing the digital data. Am I right? So in digital TV also we are broadcasting the digital data. Am I right? So the sampling frequency requirements for luminance as well as audio, sorry, luminance as and color difference signals, okay, was 13.5 megahertz, 6.75 megahertz and 6.75 megahertz respectively for YUV channels. Okay, so if you sum them up, it goes up to 27 megahertz, which we have seen in the second unit. Is it correct? Yes. Okay, so in digital recording system, what you are doing, you are having the sources first through which you are recording. Okay, so the video camera and microphone, then you are having that data, that data is digitized, okay, then compressed, then multiplexed, given to the recording system and written on the disk. Okay, so these are the steps. Okay, now Previously what we have seen recording system, now we will see the player system, DVD player system. Okay, so here you need to focus on some more parameters over here. Okay, so which are those parameters is, first of all, this DVD turn, whether it is visible on your mobile screen. Okay, let us let us zoom this one. Okay, now DVD turntable assembly. Okay, on which we are having the turnable adjustment, the servo which is used to rotate and give the proper RPM for the DVD. Okay, then we are having the optical assembly, in which we are having the laser power control, focus and tracking, these two important parameters for the laser. Okay, and these are coming through the system control. Okay, now the thing is that through this optical assembly, okay, we are connecting this block to the program stem reader and demux. Okay, now at the time of recording we are multiplexing the data, am I right? But at the time of playback you have to demultiplex the data, because you cannot play the sound on display, or you cannot display the information on your speaker. Okay, that is the most obvious thing. So properly you need to demux the sound and audio signals, exact opposite operation of the recording system. Okay, so through this we are separating out the video and audio. Okay, and this has been controlled through the CPU unit. Okay, okay, so after this one, video decompression. First we are compressing the data, now we are decompressing the data. Okay, inverse MPEG2, then scaling the YUV parameters. Okay, then there is a graphics delay. Okay, why this delay is because so as to sync that particular video with the sound. Okay, and finally the signal has been given to the NTSC or PAL decoder. Okay, right, through which we can get the outputs like S video, PAL NTSC video, YPBPR video, or RGB, simply RGB video. Okay, based upon what kind of display that you are going to connect with that particular standard, whether it is a NTSC or PAL. Okay, understood? In recording, what we are doing, we are multiplexing the sound and video. In playback, what we are doing, we are demultiplexing the sound and video and also decompressing it and giving to the some other systems like NTSC and PAL decoder. Then the audio is decompressed, then given to the stereo digital to analog converter, sorry, stereo to analog converter. Okay, and given to the stereo channels. Okay, or you can also connect the 5.1 digital audio interface system, where you are having left channel, right channel, center channel, left, rear right, and subwoofer system. These are 5 point and subwoofer is 1. So basically how this, okay, let us consider this is a surrounding where you are watching this screen and you are sitting over here. Okay, so here you are having the left channel, here you are having the right channel, here you are having the center channel, here you are having the rear left, here you are having the rear right, and here you are having the subwoofer. Okay, so this is how sound is all the way coming to you, and it is kind of a digital audio system. Okay, understood? It is very simple diagram, and also you need a power supply for the system. Okay, so this is important parameter for this one. And lastly, I guess in most of the examination in the previous syllabus, this point was there. This is the block diagram of stereo tape recorder. Okay, so I don't know whether they will ask in the examination or not, but still we will cover this one. Okay, so for stereophonic recording on the magnetic tape. Okay, so this is a stereo tape. Here we are using magnetic tape. Okay, so for stereophonic recording on the magnetic tape, we have to use separate recording heads instead of using the cutting stylus. Okay, so here we are having the recording heads, these circles. Okay, in this diagram, just it could be visible on your mobile screen, but am I right? These are the recording heads. Why? Because it is a stereo tape. Stereo, when you say the stereo, means you are having the right channel as well as left channel. Okay. Okay, instead of the cutting stylus, the recording heads will record separate tracks for the two channels. Okay, on the magnetic tape we are having two different channels. Okay, so as you can see the block diagram of the stereophone tape recorder. Okay, the output of right and left microphones. Okay, so here we are having stereo microphones. Okay, are applied to the chain of preamplifier, processors, okay, the drivers and power amplifiers. Okay, the power amplifier drive two recording heads. Okay, recording heads as shown in the figure. The balance control potentiometer ensures that here we are employing the balance control potentiometer. The balance control potentiometer ensures that for equal inputs the output will be equal, right? And for the playback mode, the output of playback head will be applied to the inputs of normal stereo amplifier and the speaker system. Okay, so it is very simple operation as far as the what we can say stereophone tape recording on magnetic tape is concerned. Okay, so in this way we have covered most of the part of this particular unit, the important part, right? Let me tell you one thing, the last thing, this one. Huh. Is it visible? Okay, so there are some lecture, okay, especially lecture number 23, 24, 25, 26, and 27. Okay, 5 lecture series, 23rd, 24th, 25th, 26th, and 27th. Okay, by Professor Somnath Sengupta, IIT Kharagpur. Okay, especially on the compression of the video techniques. Okay, so all the links of the 5 lectures I'll share in the Google Classroom. Please go through this one because in the third unit and in the fifth unit there is a importance of video and audio compression. Okay, so he has explained, he has narrated in a very simple and very nice manner how the video is compressed. Okay, so I'll share these links with you so that the concept of video recording will be covered within a very short span of time. Okay, so let us stop now and we will meet tomorrow. Okay, to revise the session and to start the final unit, that is sixth unit, and that is very 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 interesting topic of the audio video engineering, sixth unit. Okay, so thanks for patiently listening to this one. Okay, so we will meet tomorrow. I will mention the time. Okay. Okay, ठीक है, thank you, take care, bye.